without further ado, Drake Weiner.
Aloha.
Aloha.
Hi, my name is Drake. Born and raised on the Big Island. Been farming here for 27 years. My dad started Planet Hawaii's Fruit Tree Nursery in Curtistown back in the day. So if you go over to someone's house, you see a really nice citrus tree or a lot of the rambutan and longan come from Planet Hawaii. And so my dad has a good legacy of being in farming and being in progressive agriculture. And so trying to fill his shoes. Sometimes I have to dress up to do it. But as you can see, for a farmer, I just put on a lab coat and glasses. So I have a definitely different approach. Well, maybe not, I guess, but studying soil here. So I made a nice presentation the last couple days. I actually have been teaching the practical ag for Hamakua for the last 3 years now. And so I listened to my presentation from last year and I talked about a lot, and I think I went really fast. So I tried in this presentation to kind of simplify it down and slow down and really connect and make sure this information comes across. Because to me, I think that this natural farming and revitalizing our soil and getting nutrition back into our plants, because we are really eat. And so getting our plants healthy will make us healthier in return. So I called this talk Simple Tips to Unlock Hamakua's Natural Fertility, because Kaisia emailed me and said, do you want to teach, give me a topic, and I just typed that in because I thought that would be a good thing. But tonight's talk is going to be a bunch of tips, besides this tip of the iceberg. That one thing I'm going to talk a lot about are microorganisms and looking deeper down in the soil. And a lot of times, we're just looking at the surface layer. That's all we can see. And there's so much more life that's down below that can get just natural fertility. And there's even just different dimensions that if you look at this picture, you can see just there's much more hidden there than immediately appears to you. And when I look at farming, I like to conceptualize things as energy fields. That when I get a bunch of life and microorganisms in the soil, that they're putting out a good vibration, and that better plants are attracted to higher vibrations. So if I can go and approach the life or my soil in a living way and realize that it's a either a positive or a negative energy field, it's really a good way to. So that's my approach, conceptualizing it that way. And I also wanted to bring up this tip, which has been one of the biggest things that's influenced me in my explorations through natural farming, which is the second law of Babcock, which is a professor I had, where I actually got a degree in computer science instead of farming. And his law was always check long-held assumptions. He had a recipe for a pot roast. And on the recipe, it said, cut off the butt of the pot roast and put it in the pan. And so for years and years, his wife had been doing that. She had inherited the recipe from her grandma and so forth. and it always said cut the butt off. And he asked her one day, like, why are you cutting that off? Isn't that like the best part of the meat right there that you're cutting off? And so he went into it and he researched it. He really did some science and saw what was around. And he found someone that knew what, you know, he traced it down that, yeah, his grandma somehow fit. Her pan was small. So that's why the recipe, you cut it off, because that's the only way you could fit it in the pan. So it had nothing to do with this ornate recipe of preparing this ham. It had to do with this, I think the pan was too small. So I always remember the second law of Babcock, which is, you know, always check these long-held assumptions. If it seems kind of fishy to you, look into it. And if anyone's wondering what the first law of Babcock is, probably the most important, is never demonstrate anything. But, so, and also look through that, you know, guys in lab coats, like, I bought this specifically so I could take pictures of me in the garden with glasses. Well, actually, I found these glasses hitchhiking here today, and they went perfect with the lab coat that I bought, so I can take pictures so that people take what I'm saying seriously. Because, you know, all these light, these vibrations, people say, oh, you know, you're not, like, it's not science, but, you know, it is if I take pictures with a lab coat on. So I'm going to take this off because it's itchy. I'm not really a science fan. And this shirt I got from my friend Craig in Hilo. He owns Hawaiian Force, and we planted 200 pounds of kalo. Well, we didn't plant that much, but we harvested 200 pounds of kalo in a small triangle right in downtown Hilo using these natural farming methods. And I was all filthy from digging up all this food right in the middle of Hilo. We cooked it up right on site and served it to the public. And I was just all filthy dirty, and he's like, oh, here, have this shirt. So that's where this came from. My biggest tip that I'm going through and learning all about this microorganisms, and my natural farming knowledge comes from my neighbor Ginger John, whose farm tour was canceled the other day, but he has a beautiful farm. He turned me on to Dr. Park, who turned me on to Master Cho, and I went to Korea in 2009 and did a farm tour there, and whirlwind farm tour, just seeing huge strawberries, huge melons, tomatoes, a lot of persimmons, huge naturally farmed rice with way more grains than the other guys, and huge counties actually converting over to Master Cho's kind of explicit method. And in translating that here, this sort of like the disciples of him coming here to kind of get this, to spread the word of how to do this like fermentation and culturing the microorganism type of farming. And it's been interesting trying to work with a guy that you don't speak the same language in like words, but you speak the same language in like how you feel and work with the earth. So I really, you know, I feel like I share that with him when I see him doing things. He's working from that intuition. But it's been hard to get that across here as I'm teaching. One of the main things is I went to Elaine Ingham's workshop. Anyone's familiar with her? Leading soil scientist, and she showed me how to use this microscope. So I can take these recipes that I get from Korea and from all over. Master Cho got it actually from Japan. So it's kind of this ancient knowledge of how to cultivate and work with microorganisms. These enabled me to see the microorganisms, and to then test the things that he's saying, like, am I doing it right? Because over my 5 years, has it been 5 years? 2009 till 2012. My 3 years of doing this, I've been doing a lot of things wrong and or superior to what I think I could be doing. But now I believe with the microscope and with my just, you know, being adamant for 3 years, I got a pretty good foundation to build upon, and this microscope really helps me because I can verify. And that's kind of what my presentation will show, is how this microscope the microscope is just one way of looking at it. If you actually go out and you see the things, like, you can recognize it. Like, you see a beautiful plant, you know it's healthy. You don't need to get that thing out and be like, is it really healthy? Like, yeah. So I'm not like, all in one gambit of like, also, I have this question. Does anyone know the answer?
The answer is no.
No. Okay, the answer is no. Good.
It depends if you're pure.
Okay, so who pulls all the weeds?
I think it's pure.
Nobody pulls the weeds. No one goes in there and weeds it all. Like, the weeds aren't there, but no one's in there weeding them. They're not pulling out big things, making huge compost piles in one area. Nobody's weeding it. I mean, everyone's, the pigs are in there doing their thing, the menehune are in there doing their thing, the sun's doing its thing, but nobody's there, like, maintaining it to make it that way, right? So what are weeds? In the forest, are they a plant out of place? So this is what I'm hypothesizing. This is what I'm saying. It's resulting from a biological imbalance, which if you're trying to grow weeds, it's not necessarily imbalance. But your biology is determining your plant life in its most influential form, is perhaps a way of saying that. Yeah. So, what causes the weeds? Jellybees. Yes, jellybees. They cause the weeds inside of you. One of the main things that causes weeds is like natural disasters. When a landslide happens and there's a bunch of bare earth exposed, then weeds come in. They're the pioneers. And when nothing else will grow, like look at the side of the highway where they round up a lot, and you'll see like tons of Spanish needle. We have some mugwort growing out where I am. A lot of that milkweed is what I call it, growing. Those are like the Roundup. Those are the hardcore. Those are what we consider weeds, right? They're going through the nitrogen cycle really fast, and they're just burning up all the nitrogen in there, flowering really fast and dying. And that's all they're doing, really fast. And those are the things we consider weeds, because in our system, they're going to steal the nutrition from our plant. If there's this weed popping up and going through this nutrition cycle really quickly, it's going to, steal. Versus if we have these other things that we consider not weeds living in there with our plants, like a beneficial ground cover, it's not going to just be stealing the nutrients, and it's going to be persistently holding them there with your plant. So another thing that causes weeds is compaction. Like if you drive heavy equipment out in the field, you crush all that air out of the soil. At a certain depth, you'll get a really hard compaction, but at other depths, you'll get more compaction. And they're just like us. Like imagine you crush this building. Like how many people would be in here hanging out? So if you try not to compact your soil and you try to make more airspace, there's more room for life to occur and education to happen, funny slideshow. It's a clip art from the internet. And the other thing that I feel causes weeds is when we put unnatural things out, like I mentioned, the Roundup, and or just harsh chemicals out there. That weeds just tend to move into those areas. And a really weedy situation, the biology is highly bacterial. And it's highly bacterial because bacteria are really, really tiny. And when you crush them, only really tiny things can get in there. Like if we crush this building, only rats would be in here, right? Like humans wouldn't be in here anymore. So you push your system to be incredibly bacterial when you do any of those activities. So, with that said, can we mimic the weed? Oh, you guys can read. So this here where there's no weeds, look at that. I mean, nobody's in there doing that. Can we get this same thing to happen, but can we get enough sunlight down to the forest floor to grow our crops? And I was just talking to a friend of mine, Dave Sanson, and he was saying that when he goes to do permaculture here, and he's up in Mauka, Hakalau, that he has best results of replanting his edible food forests when he's clearing forest and planting food forest. If he clears grassland and plants food forest, weeds just hit him super hard. So is there a way to take that without taking more over the forest? Like, I don't want to have to come through here and cut all this down to grow my crops in there. Is there a way to do it without, constantly reclaiming forest land? And this is, again, another hypothesis. I've seen some really convincing pictures. I've done some pretty good trials, but I really haven't had quite enough time to really prove this. But I did just get a position working at Kalana Ana Ole School as their after-school ag coordinator. So I have a minion of little kids that I can assign science projects to prove this right. But I believe this is the thing, because I'm sick of weeding. And so I want to prove this hypothesis because, and I know there's ways to do it with polycultures and things, but the hypothesis presented to me and the one that I want to present to you and kind of talk about this natural farming is that it's all about getting the right fungus in there. That if I take this microscope and I go look at what's in the forest, I'm going to find there's way more bacteria, like 5,000 to 1. 5,000 fungus by biomass. So we're measuring their mass, not just how many there are, but their biomass, 5,000 times more than bacteria. But if I go out into this grass field here and I measure it, I'm going to have 30,000 times more bacteria than fungus by biomass. And so it's with that ratio that I'm saying that the grass is growing because it's 30,000 to 1. The forest is growing because it's 5,000 to 1 in the fungal figure. And that can be translated into your field. And why it's important, why to talk about the bacteria to fungus ratio is because fungus is the kind of initiator of it all. That bacteria are always there. You can't get rid of them, When it says it's 99.9% kills bacteria, yeah, those are the 0.1% that you missed right here. You can't, and this says bacteria, by the way. It's kind of hard to see, I guess. So bacteria are always present, but it's the fungus that kind of work with the bacteria, and the fungus will, the bacteria glue things together, like little bits of dirt and, minerals and things, because they're really tiny. And they glue it all together. then the fungus will come in and it'll start to ball those guys up. And when they ball them up, it's just like, you can think of it as building structures like this, but it's like putting bigger and bigger rocks together. These bacteria are making like pebbles, but if you ball the pebbles into, cement, and you build a building like this, that's what the fungus are doing. So bacteria make like these things, and then the fungus make like living spaces, like this building, by putting a ton of these guys, which they're all glued together, right? Each piece of the wall is holding another piece of the wall. But then it's like this fungal idea that we built this room inside of it. And the fungus are doing the same thing in the soil. And if you can get them in there, they naturally want to build. You bring a lot of skilled people onto the earth with raw materials, they're going to want to build things. Fungus are the same way. You give them the right materials in the earth, they're going to want to build houses, they're going to want to build freeways, they're going to want to build electrical lines, they're going to want to build waterways. They're basically going to take care of all your farming for you on the micro level, right in the soil, right where you need it. So they're kind of the crucial guys. Once they go to work, then they bring in these other guys, which are nematodes, which are miniature snakes, arthropods, which kind of look like beetles, and these guys here, protozoa, which are like amoebas, flagellum, ciliates, those funny guys you see swimming around. And they all start to work together. These guys build the spaces. These guys then, once the big guys come in, they start eating these smaller guys and freeing up food for your plant. So by building just the buildings, guys will move in and free up nutrients for your plant. Simple way of describing how fungus works. So how do we get the good fungus into our fields, right? We now know what it does, but how do we actually get it in there? And I do it by growing it artificially. That if you naturally just let the progression of the forest happen, like grasslands, and you don't graze it, trees will start to grow. Once trees start to grow, that it'll start to build back to a forest, and it will get fungus in that field. But it'll take maybe, longer than you want. So another way is to grow it, and through a specific composting Bokashi process, you can put it right into your field. I feel like I brought a bunch of guys who are really skilled in, and they're like, okay, let's build. And everyone's like, oh, yeah. Maybe everyone's not. I know. So, the way I do it, and this is the Korean method / the thing that I've kind of modified, is go to an undisturbed forest, because I'm trying to catch the best fungus. We call this method Indigenous Microorganisms. You may have heard of IMO. A lot of people have heard of natural farming, have heard IMO, and then they ask me, what do I do with it? So this is how you collect it. And I think grabbing it from the forest, like if you can go Mauka, or Mauka where you are, and grab, where they haven't grazed, and grab where it's, the ground has built up, and grab the deep coca brown leaf matter and litter from there, you'll have really good microorganisms in there. You want to go to the healthiest spot of forest, You can collect this in your backyard if you want, but I really recommend, not going to like a different island or a different climatic zone, but in your climatic zone, go to the best part of the forest in there and grab it. And I collect leaf litter from the forest, and that's all my beneficial microbes. Then I culture it on a simple starch. So, is everyone familiar with starches? They're sugars. They're more complex sugars though. And microbes love sugar. So a simple starch in this case would be a cooked starch. So this here is cooked white rice. This here is boiled column. They both equally attract and grow these microbes. Because they love sugar, because these are their starch, which means they're made of sugar, they're naturally, when you put your matter that you collected from your forest near this, they're going to jump across and be like, did you see all that starch over there? And they're going to have a party. Because when you visibly see them, there are more than 1 trillion present. So you think you have big parties. These guys know how to party. So when you visually see this, you know you got the right thing. If you have tie-dye colors, odds are it's anaerobic and you didn't get the right thing. So if you do this, you know, you cook your starch, and there's some tricks to exactly how to prepare this rice that I'm not going to cover right now, but there's a manual on all the recipes on how to do this, so don't worry. It outlines exactly how to do it. Once you collect this, it has to do with moisture, it has to do with air temperature, it has to do with a lot of factors, but you can get it onto this block or this media. Once you have the culture you want, you isolate it with brown sugar. Like I said, they love sugar, and you put the simple starch out there, which wasn't pure sugar, because you wanted to collect the ones that are a little bit tougher onto there. Then, once you had those tough guys on there, you put them into this sugar, and this is equal parts. So I took that taro skin, I carved off the outside of that taro skin, and I put that with equal parts of sugar. This is the rice one. But equal parts, so equal parts of the mold plus a little bit of that starch in with equal parts of sugar. And this enables the guys that were on there that were the tough guys to kick everything that was like a pathogen out. So this is a selecting factor that's very important to go through, because if I just got mold in the previous step and threw it in my field, they would just get, you know, overwhelmed because there's other guys in there. And if I left that taro out, you know, sure enough, in a few days it'd be black and rotten and just gross already. But if I mix it in with the sugar, the good guys take over, and then they get to a point where they can just relax. They're just in total sugar heaven. That's nice, sweet. Brown sugar is important because white sugar has a lot of the essentials taken out of it. So it's not good for you, it's not good for microbes. But brown sugar is, because it has a lot of these components necessary in there. Isolated brown sugar. Then in that form previously was stable too. You can leave it in that jar as seen for a year, 2 years, but you'll probably use it faster than that. Once you get doing it, you're just like, oh, this is so fun. Microbes start living on you. Well, they're already living on you. Your body is covered in microbes right now. And in a healthy environment, I should actually never touch anything. There should be a layer of light between us. So once you got that, you can build it up in complex carbs. And this is the complex carbs here. Notice we did simple carbs before, now we're bulking with complex carbs. Because once they were in that sugar thing, they really got strong, they kicked out the weaker guys. Now they can handle these complex carbs. And these complex carbs are what really builds a lot of fungus. So it helps them kickstart their networks going, really gets it like the kind. We're using Mill Run. It's been the most effective thing for me. A 60-pound bag is $10 from the mill on Oahu. It's definitely not a sustainable source. It's definitely not a, thing you can carry on your bike home. But it grows amazing fungus. So it's well worth it. It's worth its weight in gold. And one thing is if you're looking for substitutes of a more like what do I got on my farm? How can I grow this stuff? With what I got right here. Think cookies. Like you'll notice when you make it with this mill run that you're like, man, someone's making cookies. Because it smells like cookies. It's just like it's that complex carbs being broken into simple sugars as these fungus start to grow through, and it's cookie-like. So if anything you smell on your farm, you smell cookie. Like that's probably a good substitute. I'm thinking of using some sugarcane bagasse and some other things, but the sugarcane bagasse is too tough for them. The mill run's pulverized. It's really in this nice powdery form. And so I haven't fully perfected this system yet, but again, that's why the microscope is important, because I can do one with the mill run, put it under the microscope, do one with the gas, put it under the microscope and say, am I going towards my more fungus, the more direction I would like to travel? Mill run is the hull of the wheat. In Korea, they're using rice hulls, and it's a waste product form. They got mountains of it. They don't know what to do with it. So natural farming, using it there, that's why it's, when it came from Korea to here, that's why they used it. Here, it's not a waste product. Here, it's it's actually kind of, it's expensive. You told someone you paid $10 for 60 pounds, they'd laugh at you. It'd be like 6 tons for $10. They can't get rid of it. And when you're cooking this, notice I got a compost thermometer in here. This has been one of the things that I've been also hypothesizing, studying, looking at, but basically in nature, you never have thermal compost getting up to 140, 160, 180. You only have that when you have a crazy natural disaster and or you put a bunch of manure in a pile or humans did it, to get to those temperatures. And so because you're building the microbes that you want to be active out in your field, and that the falling detritus and all the leaf matter that falls down, it never gets up thermal, ever. You never walk on the ground, you're like, whoa, it's 140 degrees in my garden, because it's not. It's if anything, in small doses, it's around 110 maybe under the surface. And so I try to keep my pile below 120. When it's at 120, I'll turn it gently. I'm not shredding it to break all the fungus. I'm picking it up and kind of like fluff, almost like flipping eggs in a pan. And then in my theory is that when you cook it that way, then you put it out, you're getting exactly the microbes you want. You got the best ones selected from your forest that you've bulked up that now are in this amazing thing to make them grow. And then I take that and I bulk it with dirt. So this here is the finished pile. It's now, 90 degrees on my thermometer, which takes roughly a week or so. And I usually have to turn it between 3 or 5 times, depending on the weather. This is that. This is an equal-sized pile of dirt, and I'm going to combine the two together. And it gives the microbes a college education. This is like hard knock life training, because the dirt's real.
What happens right after?
Well, okay, yeah, sure. Your loans are due. And yeah, so the dirt, sometimes if you don't put in your good composted dirt, like your prized dirt into this. Put in the most red dirt you can find, because in Hawaii that means it has choke minerals in it. It's really what it wants. If you got good dirt too, also you might get some nematodes in there, which is good. I'm not saying put in your good dirt, but if you have red dirt, then you may put in nematodes, and you may put in protozoas, higher life forms just in the dirt. You're not necessarily going to, if you sterilize it by heating it, you're not going to. But mix those two together, it'll heat back up. And then I go through this final step. I didn't used to ever do this step, but now I do because I finally figured it out that I need the complete soil food web. So when we started making IMO in the beginning, we made heavily bacterial IMO. And so we put this out in our field, and it tied up all the nitrogen, and it stopped that crazy cycle of just fluctuating, and all the weeds just boom, boom, boom. It stopped that because it tied it all up, right? Now it's in the soil. It's in the form of nitrogen that's tied up, which is like flesh. So we got little dudes full of flesh in our land, and that's all we were getting in the beginning. But I came to realize that that's not, once I started learning about the fungus and things, I was like, well, it's not really the most beneficial. So I'm making mixes with more fungus in them now, but I'm also taking this crucial step of adding animal waste into it, and just a little bit. So into that mixture, I'm adding in just a tiny, I'm actually using chicken manure, because it's not wormed. But I'm adding chicken manure into it, and the best would be goat. But that adds higher life forms like protozoa and more nematodes. And you can add, you could potentially add, human pathogens in this stuff. So it's important at this step that it goes above 140 for you to be certified for 3 days. So you can't keep this at that low temperature that I was talking about with the previous steps. But but putting the animal manure in leads to those higher life forms, which then release all that nitrogen that I was storing up. So it'd be like, imagine like a bear came in the door right now and just like mauled a few people and then like left. There'd be like people left over, right? It probably wouldn't eat everybody, and some people would probably be severely hurt. And this is the same thing that's happening in the soil in a much more peaceful mindset, that all this bacteria is going around. Now these bigger life forms are coming through and just munching them. But they're not eating the whole thing. They're leaving some around. And this is the vital step that's important for your plants. Because if we tied it all up, your plants are like, hello, I'm hungry. But then the bear walks in the room and is like, I got you, bro. It's just mauling people. And the plant's like, oh, sweet, now I got a couple arms, a few legs, or barbecue grill. And it brings that higher order part of that life in there, and that completes the whole cycle going on here. And really the important part of following through this last step. Now in this pile, this also makes it super economical, and you can extend your mill run like a mile with this, is that I only put 10% of that previous mix in here. So the rest of this is open your favorite organic gardening book and follow their CN ratio. Like this much wheat to this much tree bark, or whatever you got on your land. Make their compost, but add in 10% of your matter with the soil bulked up microbes, and this pile is just going to crank. It's going to be the most beneficial. The guys taking over this pile are going to be like superheroes with bears. And that's really the key to making the whole thing work. And you can stretch it a long way and get a bunch of matter. And then, of course, you spread it on your field. There's many methods to doing this. Like, a lot of people do, compost teas or like compost extracts, or they're just straight simple put it out there. But if you come to my farm tour, you'll see this here. This is one bed. That's the soybean that probably should have been harvested a week ago, but I didn't want to have this bare field when I had a farm tour. And that's the cassava behind it, and you'll see how big it got from there. But I'm just spreading this out here. You can see it's already had grass down to kind of keep the situation out. But this grass, what did it do to my biology? Any thoughts? When I put a huge thing of grass mulch down that goes on top, what did that do to my biology? This grass, from looking at it, it got super compacted when the rain fell on it. So it cut off a lot of oxygen, made the environment anaerobic, which stressed all my biology, pushed it towards the way that I don't want it to happen. And grass is also very bacterial. It's not from the forest. It's like the extreme opposite. Grass is like the extreme opposite of, fungal forest. And so it pushed my system extremely bacterial when I did that. So what's going to sprout? The things I want, or right? So I don't want the weeds. So that layer wasn't, I'm learning this now, but I'm seeing how these affected what's happening. So when I came on top of this and I put my compost, which went through those steps of bulking up this Bokashi, it will then inoculate this and push it back towards being less bacterial, because it's like I just put a bunch of bears out there. I really like this bear idea. Raw bears. And so I put this out there, right? But just throwing compost in my field, like out there, that's like, it's not really the best idea. I mean, we work so hard on this compost, right? Now I'm just going to throw it out there? Like, are you serious? No, man, I'm not serious. I'm going to feed it. And I'm going to feed it the essence of plants. I'm going to give it, like, the nectar of the gods. Or the nectar of the microbes is what I'm going to give it. And so for 4 weeks, which is like basically a month, or you can do it, it depends if you're lazy, you don't have to do this either. But if you really want it to take hold, you feed it. And this is like a finished fermented plant juice, and I think, who's coming to the farm tour? Okay, we're going to make one of these, so I'm not going to go over it now, but anyone who didn't raise their hand, make sure you teach them how. It's super important for human health and for plant health and for health. And then oxygenated water is super important, because the microbes we want, the fungus we want, like I said, they're going to build, buildings and things, but they need oxygen before they can do that. And the deeper this oxygen goes into the ground, the better they can build their dwellings. They can get, top 6 inches of soil alive, type of idea. But they can't go down there to build it. They can't breathe, right? So even if you watered them in, or you put them on the top and water pushed them down, now they're 6 inches down, but they're like, dude, I can't breathe. So it's important at the same time you're putting them out there, you also put oxygenated water on them. Then they'll go way down deep, which by that I mean like 6 to 8 inches, and they'll start building down there. So you can build a soil foundation that's this thick in 4 weeks, right? That's what it says. Water aeration. So I wanted to do, like I said, I'm teaching at Kelowna Online School. I just started. It's really fun. These are some of my great kids. This kid's name is Ocean. Actually, I don't think I'm supposed to tell you his name. His name is Peter. Confidentiality or something. But I'm like, hey, we got to get a soil foundation going here, because it's just grass and a few planters and some things. And I'm looking around, I'm like, oh man, we got to get some good microorganisms in here, because I'm lazy, I don't want to weed. When I tell them, hey, let's go weed, they're like, can we just shovel gravel? And shoveling gravel is funner than weeding. So I want to build soil foundation, right? And groundwater, which I have access to from this hose right here, has 0% oxygen. So if I'm going to build soil foundation at this school, I cannot use the water that's there, right? So if I go down to the stream, which is just kind of over from the school, and I grab that water, I could get 3 to 5% oxygen. And the kids might want to do that. Hey, carrying buckets, who knows? They're probably into that. I guarantee they're into this one, which is if we just pray for rain, or just sit around and hope it rains, it's 8% oxygen content. So we didn't have to do anything. If we coordinate our deployment of the microbes into the soil during the rainy season or during the time that we feel really lucky or God owes us a few favors, then that's a great time to do it, because all these systems are going to work together and get the microbes, and they're going to have the oxygen they need. This is why it can rain for days and your plants are fine. But if you put groundwater on them for a couple hours, they're all wilting, dying. Their roots are like your lungs. They want oxygen. So even oxygenated water just on your plants, I'm not even talking about microbes here, they like it too. They're like fresh air. Even though they're underground, and that's why compaction, again, is not a good thing.
Hey, if you need to store rainwater, that's what it's like. If you put it on a tank, is it treated from,
It's gone. Yep. It will, oxygen will come out of the water just naturally, because when rainwater is, water is really fun. It's one of the things I really like. I'm really getting into it. It's super important to all life. And if it sits, it goes away. But as it's falling through the air, it's picking up extra electrons, which is making more oxygen want to be with this H2O. And so you're ionizing, like it's almost like ionized water when it's falling through the air, because it pulls in more, you have more things. So you can do that same thing with an aerator. So what I built here is just a simple system. This probably doesn't work that well, but these are the parts we had around, which was an old submersible pump, which is in the bottom of this thing. It shoots it up, comes around this hose, and then it hits this ruby right here, which this ruby is a rough cut gem straight from the mines of Burma. Actually, it passed through a few hands before it got to me. But it has a molecular structure to it that when I pass water around this and I have it hit it, it polarizes the water more than you could without it hitting this. So if I'm just having water fall through the air and have it hope to pull oxygen out of the air into the water, if it hits this thing, it puts a certain spin on the water that pulls oxygen into the water. So I'm not saying you have to go out and get a ruby, but any gem or any rock will put a certain type of spin on the water, which will affect its ability to hold oxygen, other minerals as well as carbon dioxide, other things like that. So if you have a favorite crystal that's on your Buddha altar, you can put it in this for 24 hours, aerate your water, put it back on your altar where it'll be in the sun. It'll be re-cleaned off by the sun, and you can have amazing oxygenated water right in your garden. This system here where I'm running this sump underwater submersible pump, because it's a spinning fan blade and fungus is long, it's cutting up my fungus. So it's not necessarily optimal what I have here, but I'm also using hydroponic fish water into the system. So I already got tons of other microorganisms and tons of things that are used to being in water in there, so it's a pretty good thing happening here. Into this aeration system, this is a 20-gallon trash can that I fill with 15 gallons, so 3 5-gallon buckets into it. There is a bag of compost, like just tea bag in it, just hanging right on the surface. And the microbes are then getting transferred into the water, and it'll actually float when it sinks. You should change it. But you can brew this for up to 24 hours. It's super, super, super essential that all your stuff is clean. So when I see this green algae inside here, this tube, that's unacceptable. But that's what I had. I'm not. We'll maybe find some cleaning materials around. I don't know. Shorten the tube. Find an easy way to clean it out. But yeah, so this is a super easy aeration system. I mean, I set this up in from just parts that were lying around. And it also puts minerals, because it'll pull the minerals off this. It'll pull the polarization, and it'll pull the microbes when I put them in the water. So, and after I water with that, I typically cover it. And
it's always just smart to practice these permaculture things, even if you're still establishing the fungus following all the things that I talked about. This is how I'm doing it currently. This is my current test, but this enables this is Gliricidium, also called Madre de Cacao, which is and I'm growing it here. I'm like alley cropping these, so I come here with my machete, and I see my machete, and I just chop this down and I drop it right there, and it's a super easy source, and it leaves these like thumb-sized branches around, which are super good homes for this fungus, which is really what I'm trying to promote. It breaks down really fast. It's amazing. I want to plant a ton more of it. So that helps too. And some tips for growing fungus are feed it humic acid. Do not buy humic acid from the store though, because that's made from coal, which is it's a horrible process of making it. You take your compost that you have and run water through it, not spraying it onto it, not like trying to like force it off, but just run water through it passively, like through a sieve or something. All that brown liquid that comes out the bottom is humic acid. So, and if you want, you can concentrate it and run that water back through a few times so you can get it nice. And ideally, if it's a really nice brown color, you've done it right. And you haven't taken the biology off your compost. It's still attached to your compost, but you've run through and you've stripped out the humic acid, which then you can feed into another compost pile or directly onto your soil or however you want. And humic acid also has a property of temporarily tying up like chlorines and other radical chemicals. So if you make humic acid and you put water into it, it sort of like purifies it. But it's not permanent, it's only temporary, or it works for about 2 weeks. And it releases for some reason. There's a dude on Oahu where doing natural farming and doing this, and he's feeding complex carbs directly to his soil, because Oahu is where the grain mill is, so they have the mill run there, and it's much cheaper than it is to ship it here. So he just buys bags of it, or like I'm talking like ton-sized bags, and just drops it all over his field, and that grows the fungus in situ, right? And it's, if you have something already really good there, and then you do this, it's a great idea. It's kind of like adding fuel to the fire, spice things up. But the other way is good too. I see a lot of, my friend gave me a Hawaiian mycorrhiza root mix, right? Like chemical, or an inoculant from, I don't know where he got it. But I was reading the back, and mycorrhiza is a really good root fungus. But on the back, it also contains trichosera, which I'm not sure if that's how you spell it, but this, if I put this in my field, it's going to kill all my fungus. But I'm also inoculating at the same time with some mycorrhiza, so supposedly the mycorrhiza will like establish, and it's a good thing. But if you're buying microbes, you're buying fungus, you're buying those things at the store, look through and make sure it doesn't have trichosera. That's one of the most popular.
Is it listed? What should be shown on the label?
If it's not listed, don't buy it.
Well, if it's not listed, you're assuming that it's not fresh.
Yeah, well, yeah.
So if it does show on the bag, that's not good.
Yeah, and there's a few others too, but this is the main one that I've seen in a few products that people are like, try this, and I looked at it, I was like, no, man. So I know it's around. Another good way of talking with Dave about this is just, burying wood. If you're going to dig a garden or whatever, just throw a big stump in there or whatever. It'll really help fungus grow. And if you're inoculating with good beneficial fungus on the top, you won't get nasty fungus that's living in there, and it won't get all gross. But the more wood that's in your garden, the more easier it is for fungal to establish. And ensuring ample detritus is kind of like ensure there's plenty of wood on the surface. But in a natural forest, why no one weeds is because it's constantly mulching itself. There's always branches decaying everywhere, unless there's people gathering firewood. And that's what enables it not to weed, is that if you don't want to weed, make sure there's a place for the fungus to live, branches, whatever. Like I said, energy field. You got to think of it, I'm still in my energy field. And like I mentioned, the other thing, like compacted soil is no good for this fungus. So it's a quick way to aerate your soil. And who's familiar with EM? Okay, EM is a product you can buy in the store. Super popular. And I have a recipe to make it for really inexpensive, but if you just get this one, you're guaranteed to get it. Put it under your microscope, make sure you bought the good thing. And minimizing compaction, of course, if you're trying to aerate, opposite of compaction. So figuring out where you're going to walk, and or if you go into your garden barefoot, it really doesn't compact. Whereas if you have shoes on, it will compact way more. Little known facts about that. And if you got like an orchard where it's already established and you have compacted soil, you've been running machines in there for years, come through, drill little holes, like go get a little mini auger, like one of those advanced tiller. Or something, and get down, make a hole about a foot or so, and you can either put these microbes directly in as compost into there, or you can just soak it with compost tea and aerated water, and that will hugely impact like a compacted orchard, bring dead forest back to life. Number of wonderful things.
How do you do that? You put the EM in the hole?
No, your compost that we made in those previous steps, which is in the recipe in the book. Once you can put your compost in there, or if you did put EM in fact when you're also, I just said feed it oxygenated water and fermented plant juice, or the ferment. If you also feed it EM at that time when you're establishing your garden bed, it's a really good time to use EM, but you don't want to use EM on a regular basis, because it's like feast or famine, so they'll use up a lot of the nutrients and then fade away, and they won't last for eons, whereas this other compost, if you use it regularly, eventually you won't have to use it because it continues to build on itself. And I run a website that has lots of videos. I went to Korea, made videos. I sometimes put jokes up there. What time is it?
They did that just for you.
Oh, really? Came with the laptop. Cool, so we got about an hour. So, a lot of times I sit up here and I talk, and then, I was talking about microbes and all these, I probably use vocabulary that's not very familiar. So, I bought a microscope for $400 on Amazon. Right? Well, it didn't come with the camera, but I bought the camera too. And this enables me to go and look at any soil sample and test these things in a quantifiable, sort of quantifiable way, and also a qualitative way, where I can't look with this thing and see the specific species that I'm looking at, but I can count biomass and see what my fungal to bacterial ratio is. I can also, I'm going to go back to the soil food website. I can also see nematodes really easily. And believe it or not, these nematodes, a lot of people talk about, I got nematodes, like I gotta nuke them. They're actually an indicator of healthy soil. And if you know the difference between root feeders, fungal and bacterial feeders, and predators, which are ones that eat other nematodes, they're extraordinarily good indicators of tilt, which is like the report card for your soil. So just by having a not as fancy of a microscope as this, but one that can get you in there, you can see these nematodes, and it's an indicator as well. But it doesn't help me get to this fungus to bacteria thing, which is really what I'm trying to balance. So what I want to do is, in just a minute, I want to give you guys a break to kind of get up, stretch around a little bit, and then we'll shift gears into this microscope. I'll get some things set up. And then we'll I can hook this thing live up so we can go around, and I brought with me a sample this is from my worm bin. So this is like vermicompost. There's actually worms in there still eating what's in it. I brought this from my compost file, which is IMO5, I just brought up that new book I'm trying not to call it. Is that finished Bokashi product, which is also known as IMO5, here. And I fed this, I collected it this afternoon from my compost file, and then I fed it lactobacillus and fermented plant juice and a tiny bit of a natural stimulator. And so since I left my house at about 3 till now, it's been sitting in that, and I also moistened it, so I think this is going to be super active. Because usually I look at it, and I look at it from a dry pile, and it's not that active, but I followed the steps of when I inoculated it into my soil. I did the same mix into this, so we'll see, if I activate it in my soil, this is what would be going nuts right now, this one. And then I brought, also this is from my tilapia pond, and it's just water. These tend to have much more cilius and protozoa and higher order life forms because water isn't compacted. And ideally the earth would have 10 feet of that compost over it. We'd be blocking like clean soil paradise. But right now in the world it's about like an inch. I don't know what the average is, but it's really skinny. Anyway, okay, so let's take a break. However you want, we'll take 5 minutes, so however you want to do with your 5 minutes.